I'm going to go rather quickly through number 13, not because it's easy. It's one of the hardest problems on here, okay? But we did it in every single class today. Every class was with it. They were paying attention. They were analyzing the problems. And all three of you classes, guys, all of you identified this as a trouble problem. So I will go rather quickly through it now because you've all seen it in person at least once. The key thing is to get rid of the fractions. To get rid of the fractions, we're going to multiply both sides by whatever the denominator is. Sometimes that's a greatest common denominator, but not on this test. But we did do some examples like that. But this time it's just easier. It's multiplying by 5. 5 in the numerator, because this is a 5 over 1, cancels with 5 in the denominator. That means I have a 44 on the left side. However, here we have to do it to both sides, not just one individual piece. The 5 up top cancels with the 5 down here, making a 19x. The 5 up top, 5 times 5 is 25x. Now we can combine like terms. On the right-hand side, we get 44x divided by 44 on both sides. And this is where a lot of people go wrong. We cancel these out because 44 divided by 44 is just 1. But people forget that canceling isn't really just disappearing. It means it just turns into a 1. So what a lot of people do is they give me this, okay? They give me that x equals 0. It's like, oh, those canceled, Mr. Sorrell. You're right, they did cancel in a way that we keep saying it, but 44 divided by 44 is 1. Again, you can double check your answer, okay? You can plug the 1 in and double check. Number 14, I had a few less questions about it. That's hopefully because it follows kind of on the coattails of number 13. Before we start messing around with the variables and moving them and all that, we can just get rid of the fractions. We're going to multiply the left side and the right side both by the denominator, which is 3. This is a 3 over 1, really. So 3 cancels with 3, and this ends up being m plus 15 divided by 1. Well, dividing by 1 doesn't do anything. So the m plus 15 just drops out. That equals 2m. Oh, I just made the big, I was talking about this in first block. I just made a huge error, okay? I was so focused with explaining my left-hand side and making sure I canceled my 3's out and the m plus 15 dropped down, that I forgot to do exactly what I was telling people to do earlier today. Don't do what I just did. Don't forget, 3 multiplies by both sides, meaning this is a 6m, okay? It's a 6m. And that's really going to change up now that we start subtracting m from both sides. It's really going to make things work out nicely, okay? 15 equals 5m divided by 5 divided by 5. We get that 3 equals m. Go back, plug it in. 3 plus 15, that's 18, divided by 3 is 6. 2 times 3, this would be a 3 now, not this one. This would be a 3, is also 6. We did it correctly. Okay? On to number 15. Guys, decimals are not hard. They just look scary. Okay? They just look bad. They're not difficult. They just look a little bad. All right? So the first thing I notice is on the left side we have like terms. Let's go ahead and clean that up. Okay? Whenever we take away a 0.87, it's going to leave us with a positive 5.13 on the left side. Check that in your calculator when you're doing these tomorrow. Be careful. Negative 4.47 plus 2.2k. Right side didn't change. All we did was combine some like terms. But now everything's going to start to change. I'm going to subtract k from both sides. I'm going to move it to the right this time. I've been moving them to the left. I'm just showing you can go either direction with these. I want to move mine to the right because this way I know they're going to stay positive over here. I've been doing this problem in one single step earlier today, but I'm going to slow it down a little bit so that you can keep up with the video a little bit better. This is going to be 2.2 minus 1. That's positive 1.2k. Now we're going to add 4.47 to both sides. Those are going to cancel. I get 9.6 equals 1.2k. Divide by 1.2, divide by 1.2, and I get 8 equals k. Double check that in the calculator. Okay, it's been a while since I've thought about those times tables. 9.6 divided by 1.2 equals 8. Okay, 8. Now we get down to our independent dependent. Been a while since we've done these. Back to second day of school. We started math early. Okay? Amelia is finally going to open up her very own donut shop for her. To start off, she is going to charge customers $8 per box of glazed donuts. There used to be multiples of these in here. I've taken some of them out. Okay, they're very redundant. But I left in this one type of example in particular because of this word per. We see it all the time. Miles per hour, gallons per minute, okay? $10 per shirt, all sorts of things. And we need to know that it's alphabetical order. Before the word per is always our dependent. After the word per is always our independent, our dictating quality, okay? So in this case, list the independent quality, okay? That's gonna be number of boxes. For the dependent quantity, what that determines, what the number of boxes determines, okay, is money or money spent. Okay, you don't really have to have spent, you just have money, dollars, you can put what it's measured as, okay? It's money. The amount of money spent, that's kind of what we're looking for there.